Running a machine shop can be a varied experience. Every new project is essentially an exercise in pretending you know what you're doing. And on a good day, the universe actually humours you. This was not one of those days, but I'm getting ahead of myself. The lathe and the mill are my most used machines in this workshop, and for good reason. They're extremely versatile. This is why upgrading tools is a thriving subgenre of YouTube, right up there with screaming guts and whatever eldritch horrors the algorithm has decided that you need at 3 AM. A machine vise is effectively a must-have accessory on a milling machine, since it's either that or trying to hold the workpiece still with your bare hands whilst accepting that you didn't really need all 10 of your fingers. My vise came with this swiveling lever, which is absolutely fine, but if I have to switch from clamping a small part to a large one, I end up winding the screw in and out endless times, which is serviceable in the same way that a unicycle is technically a mode of transport. Granted, this is the dictionary definition of a first world problem, but when you're working 50-hour weeks inside an arbitrary construct of a 24-hour day, efficiency starts to feel like a moral imperative, so I designed this. Now, I know a speed handle is hardly a novel concept, and my approach to this isn't groundbreaking, but if you'll indulge me for the next
16 minutes and 2 seconds,
maybe you'll find something useful here. Let's get started.
I'll start by making the body of the handle using this strategically placed bar of mild steel. General wisdom suggests that facing the stock is tradition, so I'll start with that. Anything to the contrary would just feel wrong. And whilst I'm at it, I'll do the other side too. Machine surfaces give me more options for referencing. Measuring the initial cut and inputting the data onto the DRO gives me a third reference point. I'm effectively spoiled for choice here. With all of that said, this feels somewhat trivial considering it's just a spigot that will be held in a collet chuck. I know that a bad craftsman always blames his tools, but being able to take heavier cuts would certainly reduce the stringy chips.
Now, it'll be clear as day to anyone with an ounce of sense that what I'm about to try was never going to work. But again, hindsight was nowhere to be found that day.
Undeterred, I decided to flip the part and drill it from the other side, armed with a fresh center drill and ill-deserved confidence, because I'm stubborn like that. And if you listen carefully here, you can actually hear the broken drill getting dislodged. A quick skim with the boring bar takes me to the minimum diameter of the hexagon that I'm aiming for.
A coaxial indicator is one of these tools that you buy and watch it grow an inch-thick layer of dust, until you finally get a project that requires it, at which point its value experiences an exponential growth spike.
Running the spindle at a low speed, it lets you dial in the center of a bore with a few twists of the hand wheels. It's by no means a must-have, but most certainly a quality of life kind of tool.
The ideal tool for this would have been a hex broach or a rotary broach, but before I could even finish the Google search for these options, my credit card spontaneously combusted, so I took that as a sign. Oh.
In the interest of not breaking the only end mill of this size that I had, I took very light cuts doing this. After all, slow and steady wins the race, or at least that's the motto for small machines.
Don't worry, I can hear you type your comments saying that a rotary table would have been a far better approach than a hex collet block. I agree. Just one small problem. I haven't got one. However, if you subscribe, I'll take that as a sign that I should get one.
One montage later, let's see if this fits. Like a glove. All it needs now is a quick deburr.
What? What do you mean I was supposed to do this on the mill? This isn't inheritance machining, you know.
Using the PCD function on the DRO, I'll drill some mounting holes which will be useful later. That's the bottom of the handle done. Now it needs a cap to go over it. I'm using a feeler gauge to set the zero position for the drills, which isn't the most accurate method, but it's close enough for this part. After drilling the hole to 10mm, I'll bore out for a clearance fit of the hexagon. This also removes the conical section left over by the drill. Lastly, I'll take down the outside diameter close to finished size and part it off.
I just can't catch a break.
Alright, fine. Hacksaw it is. The obvious downside of the hacksaw is the finish it leaves behind, and we can't have that, so I'll flip the part over and make the surface look pretty. Once again, the power crossfeed makes quick work of this. And of course the obligatory massive chamfer, although it'll actually serve a functioning purpose this time.
What you're about to see isn't my brightest machining moment, but in my defense I designed myself into a corner. Viewer discretion is advised.
I need to drill the 3 holes for the handles on this large chamfer, but holding a round part at an angle is difficult enough as it is. This is why I kept this gun barrel looking base oversized, so I could clamp it in the mill. I'll screw the 2 parts together, cross my fingers and hope for the best. I'm applying as little pressure as possible because the part is only constrained on 2 points. If you're surprised this works at all, don't worry, you and me both. An end mill is far from an ideal tool for spot facing because of the flute geometry, but that's what Loctite is for. It's not going to win any beauty awards, but given how sketchy this setup was, I'm willing to look past that. Now I just need to separate the base from the spigot and bolt it all together. I switched to a high-speed steel parting blade with a built-in chip breaker. This seems to work a little bit better. That is until I get to the holes, which is where this suddenly becomes an interrupted cut. Thinking about it, carbide stood no chance here. Unfortunately, it doesn't get much better as I approach the hex section of the part either. My god, that was painful. I'm glad that's over with. I swear I'm gonna have nightmares about interrupted cuts from now on. Just need to face the part down to thickness. And lastly, a few skim cuts to get the outside diameter to what it ultimately needs to be. For once during this project, I actually thought ahead and left enough material to do this. A little bit of sanding with emery cloth blends the two surfaces together and leaves a nice surface finish. I must admit, after all that rigmarole, this actually looks kinda sharp. Next up, the handles. Whoa, what in the fresh hell is this? That insert is cooked. I suspect that has something to do with the interrupted cuts from earlier on. There we go, that's much better. And just like that, 3 shiny handles. However, we're not finished just yet. In the interest of not stabbing myself in the hand every time I use this, I'll make some decorative knobs. I'm largely just freestyling these. The general convention is to have spheres or billiard balls in these handles, but I have this incessant need to be different. That, and I don't have a ball turner. Parting blade always leaves a small nub at the end, so I'll use the collet chuck to quickly take care of that. Whilst I'm at it, I'll also reduce them down to size. You know, every time I chamfer a part, I feel like I should be paying some kind of royalty to Brandon.
It's been a whopping 2 videos since I anodized anything, and quite frankly, I'm getting withdrawal symptoms at this point. So let's spice these things up a little bit.
parts get a good clean to wash away any acid from the anodizing bath, then they get to soak in the dyeing solution. Whilst the knobs are having their spa treatment, I'll cold blue the body of the handle, because appearances matter. There's something truly fascinating about watching cold bluing. It's such a dramatic effect. Oh, sounds like the knobs are finished. I decided to use green since it matches the signature Walker paint job on the mill, also complements my eyes. The last step is to douse it all in Loctite 603 and make it permanent. As well as a few drops of 3-in-1 oil to protect the surface from rust. Hey, would you look at that? It works.
And just like that, I've spent 10 hours making something that'll save me entire minutes over the span of the next few years. You might call this a Sisyphean sunk cost fallacy, but I like to think of it as progress. Or madness. Or both, probably. The line's a bit blurry at this point.
All that's missing now is a way to get it off the bench so I don't lose it.
Thanks for watching. I'll see you next time.
Hey, Current Day Eric here. This video took me longer than I care to admit, but there's a good reason for it, I promise you. In the meantime, I'll be going to Open Source 2025 in San Francisco from the 18th to the 20th of July. If you're going too and see me, feel free to say hi. I'll do my best to be normal. Otherwise, see you soon.